In this video, we're going to be looking at the different cases on when to perform a binomial CDF. In the other video, we look at binomial PDF, and that's when we want an exact value, when there's only either a success or a failure for your probability attempts. In a binomial CDF, we have cases where we can have different amounts of numbers for our actual outcomes. So we're going to take a look at two different types of binomial CDF problems. If you just look at these two problems, we're not going to solve them. We're just going to look at how the language is a little bit different. A family consists of 3 children. What is the probability that at most 2 of these children are boys? Is a different type of problem that's being asked than when they ask about these bingo chips and at least 3 out of the 5 are red. So when we have at most problems, that's our basic binomial CDF. I like to think it's a binomial CDF, and I'm going to use C for the different cases where I can have different outcomes. So C is for cases, where binomial PDF, P was for perfect. In a binomial CDF, we are less than or equal to in value. We use that inequality symbol, and we're good to go after we set up our equation and what we're plugging into the calculator. For at least problems, it's a little different because when I deal with at least, it's a greater than or equal inequality symbol. So I have to change it first so that's less than or equal to, so that my binomial CDF works for all the cases. So if I have an at least problem, if I have a greater than or equal to inequality, I have to transfer that first. We do 1 minus the probability of x is less than or equal to that number we originally started with minus 1. And we'll take a look at an example where that happens in just a moment. So we'll take a look at some problems now that use binomial CDFs. Very important note here, and I know I said this already in this video, but this is a less than or equal inequality symbol, and that's important detail for when we go through these CDFs. So looking at example 1, about 92% of students say they occasionally feel overwhelmed by all the tests that they have to perform. The American College Health Association found a survey last year. X is our random variable that represents the number of students who feel stressed in a class out of 10. So 10 represents our sample, it's our population. So I know that my n value is equal to 10. And when they gave us this percentage with 92%, if I convert that percent to a decimal, I know that 0.92 is equal to my probability. And now we'll answer the different questions to get the different cases. So in question A, they're asking what's the probability that in a class of 10, less than 4 students occasionally feel overwhelmed. So if it's probability that less than 4 students are overwhelmed, we're looking at P of x less than 4. The issue here is that this is a strictly less than symbol, and our goal is to get less than or equal to. So we have to change this before we begin our binomial CDF. This is the same thing as saying, what is the probability that x is less than or equal to 3? And we'll figure that out and plug into our binomial CDF plug-in for our calculator. So writing this out, and this is work you would have to show on the IB exam. So get full credit is what you're typing into your calculator. It's binom CDF equals, or of, 10 for your sample, 0.92 for your probability, and 3 for the at least amount of what we want for the probability inequality symbol. You type that into your calculator, you're going to get e to the negative number, so I'm just going to convert that into scientific notation. We get 2.02 times 10 to the negative 6 power. So if you need to pause this video at any point, try typing this in on your own and crunching the buttons. Make sure that you can do that. And that's second Vars, by the way. We got that in the PDF video. It's second Vars recording. So in part B, what is the probability that in a class of 10, at most 3 students occasionally feel overwhelmed? So if you have a hard time understanding what the language is trying to tell us, it's okay to write out the different cases that we see. So if I have at most 3 students, I can't go over 3. So at most 3 students is any amount of students from 0, 1, 2, or 3. So that's the probability of x is less than or equal to 3. So in that case, I'm plugging into my binom CDF. The same values we actually saw in part A because we had to convert that to 3 before we started. So the answer here turns out to be the same that we got in part A, 2.02, so times 10 to the negative 6. So even though they asked us different questions, we got the same result because we did have to do a little legwork in part A to get to where we needed to be. In part C, we're going to convert what we're asked to do here. So in a class of 10 students, less than 9 students occasionally feel overwhelmed. So if it's less than 9 students, that's the probability of x less than 9. So again, if I have a less than symbol, I have to convert that first so it's less than or equal to. So really what I want is the probability of x is less than or equal to 8. And now I'm ready to set that up into my binomial CDF. This is equal to binom CDF of 10 for my sample, 0.92 for my probability, and 8 because I had to go down 1 to get that less than or equal to symbol. Type that into your calculator. You should be getting 0.187882455. Okay. Last type of problem we're going to look at for our binomial CDF is the one that's a little bit different. What's the probability that at least 3 students occasionally feel overwhelmed? So if I think about how many students are in this class, 1 through 10, and you do have to include 0 here. If at least 3 students occasionally are feeling overwhelmed, at least 3 means that 3 is my minimum amount, and it could go all the way up to the 10th kid in the class. So what I just underlined is at least 3 students. So that is the probability of x greater than or equal to 3. We can't have greater than or equal to 3 if we're doing a binomial CDF, so we have to change this. So the complement of x greater than or equal to 3 for this problem would be the probability of x less than or equal to 2. And since this is not what we want, this is what we want, we're going to have to do 1 minus the probability of x is less than or equal to 2. When we do this in our calculator, it's going to be 1 minus binom CDF of 10.92. And when you type that in, be really careful. We got a lot of 9s here. It's 0.79. 349. So just make sure you transfer that from your calculator correctly. But remember, at least is that different one. You do have to change that greater than symbol into the less than and subtract from 1. So this one has a couple more moving parts before you're done with the problem. Okay, when you flip over, we'll look at a quick example looking at mean and variance for binomial distributions, and then you'll try 2 problems on your own to finish the homework for tonight. So these are the formulas given to us in our formula booklet. E of x is equal to n times p. N is the number of trials, p is your probability. That's spelled out for you here. And your variance is equal to np times 1 minus p, the complement. Sometimes we saw that in class as npq for our variance. And another quick note for you here is don't forget that variance is this. If I square root variance, I get standard deviation. So sometimes that's an important note for you to remember if they're asking you to find the variance or the standard deviation. So in this example, we're given a binomial distribution of a random variable. They're giving us the mean of the distribution is 7.8. They're telling us that the probability of the distribution is 0.3, and in part A of this question, they're asking us to find n, the number of trials it had taken. So what we're going to do is kind of rewire this a little bit backwards. We know that E of x equals np. This time n is our unknown, so E of x is our mean, is 7.8, equals n times the probability 0.3. When we get n alone, we get that the sample was 26. For the variance, now that I know the mean, I'm going to use that to help me find the variance, or I know my sample. That's going to go into my variance formula. Variance is equal to npq. So my variance here is equal to the n value I just found, 26, times the probability, 0.3, and the complement of the probability, 0.7. We type those into our calculator. We get the variance of x equals 5.46. And the last piece of this question is asking us for standard deviation. So just remember that standard deviation, or S of x, is equal to the square root of the variance. So S of x would be equal to the square root of 5.46. S of x is equal to 2.33, 666, 4289. And you just want to make sure you go back with these values, make sure you type them into your calculator carefully and that you're getting the correct answer. Try the next two problems on your own, check back with the key, and make sure you watch your second video. Thank you.